You guys are gonna do some stuff. I'm opening up the random. Yep. Oh my God! Come on, you stupid bitch.
I had 40 in total combined. There's multiple parts. That goes on letter G.
What the heck happened here? That's weird. No. Something happened here. Hello. Well, I don't know. I don't have time to look at this right now. 244. $62. Worry about it later. All right, so my random thingamajigger isn't working. I don't know why. I have to go back and look at the code, apparently. So we'll just go down the do-do-do-do-doots. So Elise, you're going to be first up.
No, reading wasn't brought up.
Yes.
Calculator.
I'm sorry, I forgot I had a mom discussion about it.
Oh, yeah.
And she's like, I'm like, well, did that work?
Sorry.
Just
wishing you that job. I know how it goes.
Hey, everybody should be working on every one of these, because if the person that I call on first doesn't get it, I'm going to the next person. Okay? And if we have to go through all 13 of you before I come up, before somebody comes up with the answer, then you're all in big trouble. So it says in the questions below, provide the sketch of the indicated area on a normal distribution curve. I don't care about that. Then use your GDC to find the value of A. Round your answer to 3 sig figs.
This is your GDC.
Yes, that is your GDC. That is what. So that's like what our picture would have looked like.
What is this? This is
12.3.
12.3.
I don't know what it is.
You got it?
I don't want to do the other ones.
We did it at the end yesterday, or last time. Isaac, you got it?
Maybe.
What you got?
Oh, like the number?
Yeah.
I don't know. Would 0.87 be the area?
Yeah.
So I got 6.25.
Excellent. 6.25 is correct.
Okay, show how to do.
So you should be doing inverse normal. So second, vars, command 3. Vars is right below the down arrow. That says inverse normal. So 0.87 is the area. 4 is the mean. 2 is the standard deviation given to us right here. Here's the hook, guys, though. To use inverse norm, it has to be written as a less than problem. So Gavin, for part B, what are we going to have to do first before we can get into our calculator since it's written as a greater than? Yup. How do I do that? This is even a chapter 8 question even. What? That's right, yeah, 1 minus 0.61. Now calculate it. Everybody try it.
Ooh.
Gav, what'd you get? Zach wants to answer.
Lifeline. All right, 208.
Yeah, we round to 3 sig fig, so just 209.
Oh, okay.
But that's great. It's exactly, sounds exactly right.
Oh, I got it. You should put the number in.
That'll do it.
208.899.
Yeah, that sounds right. Yes, sir.
Oh, yeah.
On the quiz,
Mm-hmm.
you'll just have to draw the little thing, like, because there's not much more we can show.
Right, drawing the thing is like part of like showing your work. So you have like, but this is what we actually need, right?
Oh, I didn't do the inverse one.
So, really, so for A, that's pretty much all you have to do.
Yes. Yeah.
And then B, you'd want to show 1 minus 0.61.
Sure, that'd be good.
But you're not going to take a point away if we don't?
Probably not. All right, Lucas, C. Maybe drawing the picture here to start would be good, right? So you want that section, right? Does that make sense? So what you could do is you could take like that area, and minus that area. So what is U is this.
Like 32.
Is it something wrong?
It said minus degree. Yeah, it's 16 something.
Okay. Still don't like what's going on? Let's think about it this way then. How much is this probability right here from like that piece? About 0.24? Half of the 0.8, right? That one's also got to be 0.24, right? And then how much is that probability? That's 0.5, right? Because it's half of the curve. So mu minus the probability that Q is less than mu minus A should be 0.5 minus 0.24. Which is 0.26. So let's calculate what that is. So 51.9. So mu minus A equals like 51.9. How am I going to solve for A? I'm going to subtract mu, which is 55, and then divide by -1. So that should be my A, about 309. Does that feel okay? Good, because you're going to do it again on part D. Yeah, there's chargers on the power strip there in front. Mhm. Go ahead, Lucas.
Are we gonna do some activity?
I want to get through this stuff first. We'll see. It's a short activity, so I think we can do both.
Got 130. Oh, 130.
Yes! Yes! We'll take it, right? I won't even bother writing anything then. I just showed you how to do it the previous one.
Is it the exact same?
It's the exact same process.
How's it shift equal to?
Yeah, does the or equal to matter for a continuous distribution? No. The reason is, if there's infinitely many values, what's one of those values out of infinity? What's the probability of that happening? 0. So it doesn't matter for a single value.
Okay.
Does that make sense? So again, less than or equal to, less than whatever, it doesn't mean no, nothing. All right. In a standard normal distribution, what does standard normal mean, Matt? What is that telling us? What's the mean and standard deviation? That's what it's telling you. The mean is 0. Standard deviation is 1. Okay, so when we say standard normal, that just tells us the mean and the standard deviation for our distribution. Okay. It says 20% of observations are above what value? And then what does this value represent? Right? That's kind of what the problem is saying.
So when it says 1% of the observations are above what value, so that value would be the area.
What value is the A?
Okay.
Right? Megan, you got the number? Mm-hmm. Yeah, 0.842. What is that saying then? It's because it asks, what does this value represent? So if 0.842 is 20% of the observations are above that value, what percent are below? 80. That is the definition of, it's from first semester, starts with a P. It's a percentile. So this is the 80th percentile. That's what you would say, what does it mean? So the score of 0.842 is the 80th percentile. Okay. All right. The heights of 3-year-old females are approximately normally distributed with a mean of 94.5 centimeters and a standard deviation of 4. What is the third quartile of this distribution? Luke. Okay. What does third quartile mean?
So like the top 25%.
Yeah, it's the 75th percentile. So if we have that normal distribution,
And then standard deviation, how would that be represented, like in a, like simple
sigma.
sigma?
Mm-hmm. It is, Elise.
Oh, yes. I got 89.89.
That isn't correct. That's correct, though. 97 point, well, you rounded to 2. Yep. Did you figure out what happened there? You did inverse norm 0.75.
Oh, I put center. So that's 0.75. I did.
Oh, instead of doing left or right. Yeah, I gotcha. Okay. Diego, what's the IQR for this distribution? How do we calculate IQR again? Q3 minus Q1, right? We know Q3 from the previous problem. You just need to find Q1 and then do a little bit of subtraction.
So I do inverse norm, then
Mm-hmm.
quantifies the area.
Mm-hmm.
Mean is 94.5. Standard deviation is 4. So that's 91.8.
Okay, when you subtract the 2, we get
5.4.
good. All right, Christian, you got a picture. The following histogram gives the distribution of incomes in thousands for graduates with a degree in business administration. This distribution has a mean of 64,580, a median of 61,425, and a standard deviation of 14,700. Describe the mean, median, standard deviation, and shape of the distribution, or shape of the standard distribution of the same data.
How would you even describe the mean, median, and standard deviation?
Well, let's do the mean first. Since it's talking about a z-score, our new mean would be the old mean minus the mean divided by the standard deviation. Or duh, we know that it's a 0, right? Our new median is going to be the median. Hi. Minus the mean divided by the standard deviation. We're just going to convert that to a z-score. Whatever that comes out to, let's see, what do I have? Negative 0.215. Our new standard deviation. Well, what's the standard deviation for every standard normal distribution?
It's just 1.
1. Now, do you have to do anything to show that? You don't really have to. Just like the mean, you could have just written it down as 0 and just said standard normal. Always the case. All right, so we've done this. So we did the mean, median, standard deviation. Now let's talk about the shape. If I do that, same z-score translation to all the data in here, is what's going to happen to the shape?
I don't know, would it be skewed in one direction?
Well, what is the shape currently, if you look at the picture?
Or looks skewed right?
Correct. Now, if I subtract the mean from every data point, it's going to just shift everything
Left.
left, right? But is the shape going to change? No, right? Because everything is still the same amount apart. If I divide it by the standard deviation, everything divided by the standard deviation, that's going to do what to the data, or what to the picture?
Would change it.
Right, but what's it going to do? Proportionally, it's just going to change the distance between everything.
Yeah.
Like it's just going to like shrink it down. But is the shape going to change? No, because everything is changing by the same, like proportionally amount. So like
Yeah.
the shape is going to remain the same, even though we've subtracted and then divided. So since it started out, the picture started, the shape is,
Skewed right.
after we do all this, it's still going to
Still
be
gonna be the same.
skewed right. Yes. That's the takeaway. Does that make sense on kind of how to think through that?
Yeah.
In general, that's the point of doing this standard conversion, is that the shape doesn't change. The data is still ostensibly the same. It's just like, here's a picture that's easier to deal with.
Does it always stay the same in a standard normal distribution?
Yes. After you convert something to if something is approximately normal and you convert it to standard normal, the shape will stay the same.
Okay.
All right. 14. Boy, this is like the never-ending problem set here, huh? Or example set. Aiden. Toy blocks are made such that their lengths are normally distributed with a mean of 6 centimeters and a standard deviation of 0.2. The bottom 12% of blocks are rejected for being too small. Find the minimum length to 3 sig figs that a block must be to be accepted. So translating that to symbols, the first sentence just tells you the type of distribution, right? The second sentence then says the bottom 12% of blocks are being rejected for being too small. So the probability that your block is less than some value should be 12%. We just need to figure out what that value is. Does that make sense on how I've changed this into symbols? And now it looks just like the questions we started with, right? All right. Can you do it? Do you remember what you need to use on your calculator to do this?
Yeah, it's do you want to go second and bars?
Mm-hmm. Mm-hmm.
And then you put stuff in.
Yeah. What goes in for area?
Which one?
The probability.
Yeah.
What goes in for the U?
6.
The mean. And what goes in for the sigma? The standard deviation, just 0.2. And then you just press enter.
Yep, she gets 5.7.
Good. 5.77, I think. And that should get a unit here, because we're talking about real things. But does that feel okay?
Yeah.
All right. Zack Attack. Baseballs have diameters that are normally distributed with the relationship B is normal 232, 3 squared, where the diameter is measured in millimeters. If the smallest 5% and largest 5% of baseballs are rejected for being either too small or too big, find the minimum and maximum acceptable diameters for baseballs rounded to the nearest millimeter. So you have two things to figure out, right? So P of B, if it's greater than A, that's 0.05. And then P of B less than A should also be 0.05. Well, actually, we just call that A1 and that one's A2. Right? So we have to figure out what A1 is and what A2 is.
227.
Yeah, we'll just round that to 3 sig figs, so that's 227. And that's our minimum, right? Because it's a less than. Mm-hmm. Yes, very good. How do you do that?
It's 1 minus 0.05.
Yes, correct. .95. What's when you do the inverse norm though for it?
Oh, yeah, I just.
Yes. Does that feel okay?
Perfect.
Again, the calculator is going to do all the heavy lifting for you. You just have to figure out, like, how do I put it in there, right? And it's not super complicated, but there's like some reading comprehension that comes into play so that you can get it into symbols and then make it easy on yourself on how to get it into the calculator. All right, Alexis, the mean size of pencils is 7.5 inches. If a sorter finds the smallest 8% of pencils are less than 7.22 inches in length, find the standard deviation for the pencils in inches. Round your answer to 3 sig figs. I'll give you a hint.
Do that. Set up like this score and separate things.
Yeah, so you'll want to start with this and find the probability that Z is less than, the probability that Z is less than A, and it's 0.08. So what do we get for A then? Oh, actually that should be, I'll make that a little z.
So do I put this in my?
Correct.
Okay. So would the area be 0?
Yes.
Okay. And then the mean is 7.
Nope.
Oh,
We're doing a standard normal.
so it's 1.
So the mean is 0
Oh,
and the standard deviation is 1.
okay. Then it's less than you do left.
Correct.
And -1.41.
Okay. Now that's your Z score, right?
Yeah.
And we know Z score is equal to our measurement minus the mean divided by the standard deviation.
Yeah.
So we can say negative 1.41 equals our measurement minus our mean.
5 over.
Oh, and then 7.22 is the measurement, right?
Right. And then you do your Algebra 1 skills.
Mm-hmm.
You do both sides of it. Like you times it by both sides, and then you do the 7.22 minus 7.5 over 1 negative 1.
And what do we get?
Oh, I didn't tip it.
Oh, okay. But yeah, that's
I will
right.
take it, tip it.
Yes, inches.
Engine?
That's one of the harder ones you guys will be asked to do. So again, if you're given a distribution and asked to solve for standard deviation, you're going to have to use a z-score to do that, right? So you're going to use a standard normal distribution to find the equivalent z-score and then have to use that conversion back to get the actual measurement, right? All right, last one, Elise. The mean weight of a bag of apples is 6 pounds. A machine rejects the top 15% of bags for weighing more than 6.83 pounds. Use this information to find the standard deviation for the weight of bags in pounds. Same idea as the previous one, right?
Yeah, so,
Oops. We have to be a little bit careful because this one is written as greater than.
okay,
So what do we have to do to change that from greater to less than? Mm-hmm. So that's what we're going to use in our calculator. Well, some of you guys that have the new calculator, it has like left, right, center as an option. If you don't, the only thing it does is left. But if you have left, right, center, you don't have to do the switchy. You can just be like, oh, it's greater than, I'm going to pick right. Or, oh, it's in between two values, I'm going to pick center. You can do it that way, that's fine, if you have a calculator that does it. I don't assume that most of us have that calculator. Because if you bought yours years ago, you probably don't. If you bought one brand new this year, I think it does. Does that make sense? Okay, Elise, did you get the 1.04?
yeah.
Okay. What do we do now? We know that, right? That's our z-score formula. So 1.404 is z. Our measurement is 6.83. Our mean is 6. And we're solving for sigma. That's the standard deviation. Did you get it?
1 second. Oh, I put the 1.04 on top by accident. Yeah, I got that.
Good.
Mr. Cole, does the total like chopper stuff
Yes.
Standard norm, the mean is 0. Say deviation is 1.
So this is the
It's just the
the activity here. So with a partner, you guys are gonna be timing how long you can hold your breath for. So you're gonna have,
No, that's gotta be crazy.
you're gonna have three tries. So
I'm so bad.
you have 3 separate breath holds. So take the So find a partner and make sure you have a timing device, probably your stopwatch on your phone would be fine. Once you guys have your times recorded, come up and tell them to me and I'll record it up here so we can get a class ranking.